So this is the second video that I'm doing about setting AWS Workspaces up for an education provider. I provided a bit of context in the first video, but just to recap, we have used EC2 instances to provide remote desktops for students, and I'm looking into the possibility of using AWS Workspaces for that, for a more straightforward admin experience and a better student experience. We're using virtual machines so that we can provide a consistent environment for students, so the same operating system, the same version of operating system, the same software installed, again at the same versions, configured the same way, so that we can ensure that all students have the same computational resources available and they're all getting the same experience, and we don't have to spend time during tutorials solving questions like how do I get this to run on Windows 7 or so. That's the context. In the first video we looked at the basic architecture of the backend for Workspaces that we're using, the process of provisioning a new workspace, setting up a new user account, and that initial sign-up experience for a new Workspaces user. So from there we're going to pick up with a workspace that I've got set up. We're going to get signed into that. We're going to configure that for students to use. I'm going to show you the automation that I've got around that, explain why things are done the way they are. So you'll probably remember this basic view from last time. We have a workspace deployed. It's a different workspace. I have destroyed and recreated the workspace in the meantime. It's currently in a stopped state, you'll notice here. So when we sign into this workspace, it will kind of give you an idea of how long it takes to kind of get a workspace that's been suspended up and running. So we will get started by getting signed in. As part of this process, I'm going to show the password reset mechanism that's built into this as well. So first of all, I'm going to start the Workspaces client app. I need my registration code, so that did come in my email. Just because I've got this screen sitting here, I'll grab it out of here. There's the login page. If I can't remember my password, I can just hit the forgot password control here. So as a student, so it doesn't need any administrator intervention. Enter my Workspaces username, so I am student. I need to fill in the captcha. Go and recover password. Okay, so here is the password reset email I received after going through that process. I get a reset password link. You can click the link there and create a new password. But would recommend use of a password manager to generate a strong password for this, of course. Reset, and then finish with that process. So I can close that down and get rid of my email. Get rid of that. Go back to the login page. I can log in with my new credentials. I'm told that it's resuming the workspace. So there is a reasonably good amount of feedback that the student can see, the user can see, about what's actually going on. If things are taking a little longer, they can see the workspace is resuming. It's not just hanging as a connection, as you might see from a normal like VNC client or something. And here you can see the workspace has resumed, and I am looking at the desktop. That took certainly less than a minute. I'd say probably somewhere in the region of 40-50 seconds. So really not a very long time. Once the workspace is up, then connection is quicker, as you saw in the last video. But if it has stopped, it's not an excessive delay under normal circumstances to get up and running. So now it shows as available because I've logged into it. Okay, so that's password reset, cold start. So let's get this workspace set up. So first thing I'd suggest that users do is, in fact I'm going to make it full screen, there we go. First thing I suggest the users do is set the keyboard map. So if you've noticed in the last video, the workspaces by default are set up with a United States keyboard map. which may cause problems. For example, when I hit Shift and the number 2, I'm seeing the @ sign here, not a double quote. So in particular, if you need to type, you will need to type the user's password in, or the user will need to type their password in. If their password contains a character that is mapped differently on a US keyboard to their preferred keyboard mapping, that could cause a lot of confusion for me in the past, where I've not noticed it. So I would suggest the first thing to do is just to make sure the keyboard mapping is set correctly. There is a user interface to do this. So if you go down here to System, Preferences, Keyboard, you have a Layouts control here. We can add a new layout. Let's choose English for me, as I am used to a British English keyboard, so English UK. There we go, and I can have a C, so there you go, so there's number 2, Shift for 2 is a double quote, that's what I'm looking for. So I'm going to add that, and I'm going to make that the default. You optionally can remove the US locale and close that window. So yeah, so now Shift 2 is a double quote, so should eliminate any risk of that. You can also set this at the command line, but setting at the command line and ensuring that it applies to next time the workspace reboots is where you might run into difficulties. So probably using the user interface is probably easier for most students, and if they do want to use the command line, they can probably figure that out for themselves. So that's the first thing. Now we are actually going to go get all of our software installed. So I'm just going to show you this working, and then I'm going to go back and show you how the automation works and the quality controls I've got in place over that. So I'm going to open Firefox up on the workspace. I'm going to go to a repository. So I've currently got this in a repository under my own GitHub account. It would be under, of course, a different GitHub account, but the key thing is it's quite straightforward. The URLs to a repository in GitHub are not very complicated and can just be typed in pretty easily. So let's do that. github.com/ that's me, and then the repository is AL2 Amazon Linux 2 data sci setup, and that's the repository. What I've got is a README here, which I can copy and paste, but the right keyboard shortcuts will work fine here too. Okay, so all I'm going to do is copy down the script here onto this machine. There we go, and there's the script setup.sh. I'm going to update the permissions so that I can execute that script. I'm not going to show you what's in the script, we'll go through that shortly. I'm just going to get it running. And pop. So this is where I need to type in my password. So again, this is if the keyboard map was off, this would be where we'd trip up. That should be fine now. And there we go. So the script itself, so this is running. You can see this. I'll just open the script here alongside so we can see what it's doing. So there's a bunch of, this is a bash shell script, and there are a bunch of functions that are performing some of the more complicated steps in a more modular way. The script really starts here. So we update the packages on the system, make a backup of the bash RC profile file, do some installation of Docker, and I'll explain what's happening here shortly. Install VS Code, which is the ID that we're using. We install and set up pyenv, which allows us to control the version of Python that is being used for users more easily. And that will also install Python, a specific version of Python, Python 3.8.13 in this case. This sourcing updated profile is picking up the changes that we made through pyenv into the current shell before installing Python and checking the version, which we should be. This is about where we are now. So sorting our data profile and now install Python 3.8.13, and that's basically happening. That's what this is doing. After that, we install pipenv, which is the package manager that we are using certainly for phase 3, before finishing up with installing command line tools. So it does take a moment to install Python 3.8. So you notice the script has worked fine so far, there's been no issues. So the measures that I take to try to ensure that's the case are using GitHub Actions to do as much as I can, to do as much of the running of that script as I can in an automated fashion. So one of the challenges with this sort of approach, this sort of a scripted installation, is that when I run the script, I've then changed the state of the machine that I'm currently working on. So resetting back to a known initial state, so you can run again and make sure that the automation actually works from that initial state is really important. Really helpful to be able to do that easily. So I'm using GitHub Actions to do as much of that as I can of that. Now GitHub Actions are essentially automation. There's the GitHub action I've got, I will show you the details. So I've got this definition of what to do. Essentially, this GitHub action is saying that when there's a push made to the repository, as in I've changed something, or on a schedule of every day at midnight, I want you to run the automation defined in jobs. So the jobs runs in a VM, which is the VM is a Ubuntu VM, the latest version of Ubuntu that's available. But so Amazon, the workspaces themselves run on Amazon Linux 2, not Ubuntu. So what I then do on top of that is install or start a container running Amazon Linux 2. I also don't have super user access to the Ubuntu VM that I'm actually running the build on for, I'm sure, very good reasons, for GitHub's reasons. Running a container, there's certain things I can't do. So and the only thing I can't do in terms of this installation script is install Docker. It is possible, I think, to run Docker. I could run a Docker in Docker kind of setup, but at this stage I don't think it's worth it. I'll explain why in a moment. I can test most of what I need to test without doing that. And the steps define what actually happens when I do a push or when on this schedule of midnight every night. First thing, I install tar and git because they're necessary to actually do the checkout of the code. I then check out the current version of the repository. Set up a user account so that I'm running the setup script in a more realistic way. Otherwise, I'll be running as root on the machine, and the permissions will be completely different to a normal user. And lastly, I actually switch to the user that I set up, which I've called tester, and run a command, and I run the setup script in the repository I've just downloaded, this setup.sh. So it's basically setting up the container to be as similar to the workspace environment as I can, and then I run the setup script in there. And when I push all the schedule runs, then I get a new run, which I can see in the Actions tab here. You will see it took me been quite a few of these that I've run. I set the schedule up just today, so there's no scheduled runs here. Here's an example of what's going on. This was triggered by a push. It was successful overall, so nothing broke during this installation, and it took about 3 minutes. Okay, so I just switched to my actual laptop here, which I have authenticated into GitHub with my account, so I can see what's happening in these jobs. So yeah, you can see install prereqs, there's now a twist at the side of it. And there you go, so there's the run yum install -y tar and git that we saw a moment ago. So essentially, GitHub is just running all those commands and then the setup script on a container, which is set up to be as similar as I can get to the Workspaces environment. The one thing I draw attention to really is just there. So the reason the setup script actually checks, as we saw, the setup script checks for whether or not we are running in a CI environment, so that it can choose to skip the Docker install because I'm not set up to have Docker work on this container. The Docker installation is a small part of what the script does overall, and it's a relatively simple part as well. So I've not really had the need to do anything more to ensure that that is running in automation. This has proven, this approach of creating a container that's as similar as I can get it to the installation environment, and then running through as much as I can of the installation process, even if it's not completely running through. I found it to be incredibly helpful in terms of debugging, speeding up that process of debugging and building out the install scripts, making sure they work. And I've so far not really seen any issues with problems that did not occur during the build on CI, on GitHub here, causing me issues when I try to install it on the real environment like Workspaces. I use a similar approach for my own laptop builds. So finding it to be productive and effective. So there we are. So we have now completed our installation. So the script ran through without any issues. You'll see tools like htop, etc. So that some of the things that I was trying to install are now available. I can start VS Code. And Python in this shell is not working. That's fine, because I would need to resource the bash RC to make that work if I start a new shell. This is Python 3.8.13 because this bash shell has started. It picked up my reminder to install software updates and running Python -version. The path on this shell is set up correctly with pyenv, so this shell, when I ask for Python, I see Python 3.8.13, not Python 2.7.18, which is the system default.